Okay, so for this first one, since it says dt, that implies that t is the variable and c and k are constants. So for that reason, let me take a c out to the front, just to get it out of the way. Now, perhaps now we can make a u substitution, where we will let u equal, why don't we let u equal kt? And if that's the case, du equals k dt. Now I can divide the k underneath here, so that 1 over k du equals dt. So this is what we have so far. Now let's make the appropriate substitutions. C stays. Integral symbol. E to the kt, well, e stays e. But kt gets replaced by u, and dt is here. So that's 1 over k du. Well, I can drop the du here, and I can bring the 1 over k out to the front. So this becomes c over k times the integral of e to the u du. But the integral of e to the u is just itself. So you get back essentially c over k times e to the u plus, I'm not going to use c because there's already a c there. I'll just put like a d. See what I'm saying? Because usually it's plus c, but there was already a c there, so I'll use a different letter from the alphabet. That takes care of this one. For this one here, why don't we distribute? Let's distribute this x to the fifth to all three of these terms. So we'd get back something like this. Now you're saying, how did I get 11 over 2? Well, when you multiply these terms, you add the powers. So 5 plus 1/2 is 5.5. You turn that into an improper fraction to get this back. Now why don't we just take antiderivatives term by term. So we have the antiderivative of x to the fifth dx minus this here, and then plus, right, we're going to take antiderivatives term by term, where this one's pretty immediate. This one's going to be what? X to the 5 plus 1 over 5 plus 1. This one would be x to the 11 halves plus 1 over 11 halves plus 1. This one here, why don't we make a u substitution? Why don't we let u equal x to the sixth, so that du would equal 6x5 dx. But maybe I can drop the 6 over here to this side. So that's 1/6 du equals x to the fifth dx. So these have been taken care of. We're focusing on this term. We did use substitutions. So let's rewrite this one with all of these parts here. So my work is a bit messy, but try to stay with me. So this gets, I'll show my work down here. So plus integral, well, let me cover e to this power first. E stays e, but x6 is u. Now look at how x5 and dx pieced together are replaced by 1/6 du, where the du goes here, but the 1/6 goes out there. Okay, so now I think we're actually ready to finish this problem. So let me just drop this one here. So that's x to the sixth over 6 minus 11 over 2 plus 1 is 13 over 2. So this is also 13 over 2, which reciprocates the 2/13. And this is 13 over 2 plus 1/6. The antiderivative of e to the u is just e to the u, which is kind of what we saw here. So this would just be e to the power of u. But what's u? X to the sixth. And I suppose we can put plus c. Okay, so the key for this problem was to actually distribute this x to the fifth and then integrate term by term. Here for this one, we needed a u substitution.